Hello friends, today we are going to discuss an interesting question which is also a previous year question for GATE. So pause the video and try to read it. So the question is, for the circuit given, we need to find the magnitude of current through this 3 ohm resistor. Given that the voltage drop across this 5 ohm resistor is Vx and also there is a current source whose magnitude is 0.04 Vx, where Vx is the voltage across this 5 ohm resistor. So this is a voltage dependent current source. So as per the question, we need to find the current through this 3 ohm resistor. Given that the voltage across this 5 ohm resistor is Vx, so we can get the current through this 5 ohm resistor as voltage across this 5 ohm resistor divided by 5 ohm. So the current through this 5 ohm resistor will become Vx by 5. As we can see, this 3 ohm resistor and 5 ohm resistor is in series. So the current through series resistors will be same. As we can see, this is the current through the 3 ohm resistor. So both the currents are same. So the current through this 3 ohm resistor will become Vx by 5 as both are in series. We can write this 0.04 Vx as 4 by 100 into Vx. It can be simplified as Vx by 25. So the current delivered by this voltage dependent current source is Vx by 25. This current reaches this junction and also Vx by 5 current leaves this junction. Now we need to find a current delivered by the 60 volt source also, which is the current through this 5 ohm resistor. For that, assume the current through this 5 ohm resistor as V. By applying KCL at this junction, we can get the current through this 5 ohm resistor. According to KCL, the algebraic sum of current entering a junction is 0, or also it can be termed as current entering the junction must be equal to current leaving the junction. So as per KCL, the current entering the junction is the current V and the current Vx by 25. So it can be added, which is equal to the current leaving the junction, which is Vx by 5. Solving this, we can get the value of the unknown current V as 4 Vx by 25. So the current through the 5 ohm resistor is 4 Vx by 25. Now we can simply apply KVL on this loop to get the value of Vx. According to KVL, the algebraic sum of all the voltages inside a loop is 0. It can also be termed as voltage delivered is equal to voltage drop. So the voltage delivered here is 60 volt, which is equal to the voltage drop across this resistor is current through this resistor into the resistance value, which is the current is 4 Vx by 25 and the resistance value is 5. Both multiplied to get the voltage drop across this 5 ohm resistor. And also the voltage drop across this 3 ohm resistor is Vx by 5 multiplied by 3. And also the voltage drop across this 5 ohm resistor is Vx by 5 multiplied by 5. Solving this, we can get the value of Vx as 25 volt. Now we can easily get the current through this 3 ohm resistor, which is Vx by 5. As we got the value of Vx as 25, the current through this 3 ohm resistor will become 25 by 5, which is 5 ampere. So the answer to our question is current through the 3 ohm resistor is 5 ampere. Just for analysis, we are going to simulate the circuit in circuit lab. So now we are going to provide the parameter 60 volt to the voltage source so that we got the 5 ampere current through the 3 ohm resistor, which is shown in the ammeter, and also 25 volt across the 5 ohm resistor, which is the value of Vx. If you like the video, please subscribe to my channel for more such videos.